Welcome to session 6 of Hypermesh Radio's interface demos. So in this session, I'll be showing how to create output blocks. So in simple, these output blocks are required uh, to request result for different entities. In a sense, like you may be interested in extracting many results which should come in a graphical format or a plottable format. Like for example, you may want to see the contact forces, the forces which are coming on the springs. You want to see the part-wise energies. You want to see some acceleration plots. So, like this, like various plottable informations are possible. So this is an important stage at which you have to decide, depending on the kind of analysis what you are doing. So what are all your result interest? So without this section, if you run your models, of course the model will run and you will be having some animations and some contours, but you will not be having much results to post-process and understand the measurable entities. So this is a very important section where at this stage you have to decide like for the kind of analysis what you are doing, what are the results what you want, and you have to request all those results at this stage. The other results like the contour results which may be stress and strain, so that will not come in this section. That we call it as a contour results that we will request in engine files, so that I'll be showing you later. So in this section I'll move to the model. So I have the model here from till the where I built it last time by defining some masses and some like motor volume for the tires. So I have that model. So now here I'll be showing some basic minimum output request which should go into this section. Okay, now let me create that. So in this one, the first thing is all the 2D and 3D part should get into output request, so that at the later stage, if I face any run issues, I'll be using these results to see that where exactly is the issue. And also for the purpose, maybe if there is a change in the mass and those things, I can plot from these results. So now here I created something like output block. Let me name this one for the parts. And here I've changed the entity as components. So you can see the change here, it became th part. Th is time history. And here I will isolate 2D and I will add 3D. So thereby I have only 2D and 3D parts. And now at this section I will select all these components. Okay. So one thing what you have to remember here is for the selected part, there are various outputs which are possible. But most of the times, the default output what we generate for this part that will be quite sufficient for you. So we have to specify which type of output you want. So that I will declare it as a default. For that, the procedure is I have to say number of variable as 1, and variable type is default, which is DEF in capitals. Okay, so there are other variables are also possible. For that you have to get into the document and you have to see if you have any particular request from those components. Otherwise, most of the times the default output for a given entity it will be quite sufficient. Okay, so now I just created output block for our time history for all the parts. So this is the first one and the most important. And in a similar way, so since I have some contacts, I may be interested in these contact forces. Okay, so for that I will change the entity as groups. Okay, so in the groups again there are two varieties. So here in this case I think I have yeah. So we have removed the R wall here. We have the R wall for the other frontal impact case. So if we want to know the forces which are coming on the R wall, then we have to change the we have to change the keyword here from inter to R wall. If like we want to extract the information on the R wall. But in this case, yeah, it's inter itself means contact. So I want to see the contact forces. So this impactor, it is compressing the structure. So there will be some forces. So I will select that respective group here. So I will select this impactor to body. And again the same procedure, number of variables 1 and variable is default. So default output for contacts are all the contact forces. Okay, so I'm done with that. And other information which you may be interested in is, so I have many springs here. So I have springs for suspension also, and I have springs for welding also. So and I have springs for bolt also. So you may be so you may want to extract forces on these entities. So I will add the spring and I will switch off these entities. Okay, so now I have springs here. So for the sake of easiness, you can create here multiple spring output also. Maybe you want to create one spring output for only welding and one for only bolt and one for suspension. You can do like that. Okay, but just make sure that you don't repeat it. Means you don't put an entity in multiple output blocks. So that will lead to error. So here I will go with the elements and I have to say which type of element I am interested in. So here in this case it is springs, and I can select, so basically I'm selecting some bigger suspension springs here. Okay, so I have selected, and again this is same variable def close. Yeah, so spring is done. In a similar way you can create output request for rigids. So on the rigids also you'll get the forces and moment. So I will create one more output block. So again this time the entity is element, and element type is R body. Okay, so I will make the selection. So I'm selecting some rigid bodies here. Fine. The number of variables, again it is same procedure. There. Fine. Okay, so now if I'm interested in studying maybe the acceleration, then the procedure is a little different. First I have to create, okay, let me name this. Okay, so for that first I have to create an accelerometer, and then I have to call that accelerometer in this output request. So how to create accelerometer? For that you have to create one sensor, and that sensor type is, it's an accelerometer. Okay, so I have to say that in which node you want to measure that, normally on the engine tunnel. So this depends on the data, like how you have. So if you have some testing data and if you have the information like where the accelerometer was exactly mounted, so in the model you can make the same selection. And the cutoff frequency, I will use some standard cutoff frequency. So I have created an accelerometer. Now I will call that accelerometer in the output block. So this time the output block is sensor. So it is showing by default it's acceleration sensor. Otherwise there are some other things are also possible. So I will choose the sensor what I have created. Again the procedure here it is same. It is the year. Fine. So now with this I created various output block. So as I told, it is not limited to only these entities. If you see the selection here, okay, so there are many things which are possible here. Okay, maybe like one more thing what I want to create is, since I have created monitored volumes here, I want to create one more output request for the monitored volume by selecting this as control volume, and I will select the motor volume whatever I created. So I'll get the information like how the pressure is changing, how the volume is changing. So all the information I'll get for this motor volume, which is quite a very important output request when we are dealing with airbags. Okay. Uh, yeah. So with this, I have created a set of output blocks. So all the results for these entities will be written in a file, T file, when we run the simulation. So all the information will come in a T file. So that file we can pull in a hypergraph and we can see the results. So we come to the end of this section. Thank you.